Okay. Just a quick recap of what we have done till now. So we started with the unified process, and then we started looking at various diagrams, various artifacts that are drawn using the unified modeling language, right? And the first one that we started with was the use case diagram. And then we move ahead to discuss use case text scenarios. Now, use case text scenarios, we studied 3 formats of writing use case text scenarios. And the most elaborate one was the fully dressed scenario, right? And then we did the domain model. So the domain model was something that we ended with in the last lecture, the third lecture. So the idea was to identify the various domain concepts, which I think would be a challenge for most of you, because most of you are very much familiar with drawing class diagrams, right? And class diagram is the second step after creating the domain model. So when you try to draw the domain model, it kind of ends up turning into a class diagram, right? So you have to be really careful while you draw the domain model. I'm getting message from only one person who's saying that the voice is too low. Please check your connection. Voice from my side is maximum, right? Okay. Just a couple of things before that, before I start today's session. I have posted 2 important announcements. The first one is the syllabus of quiz 1. Quiz 1 will be conducted. You can continue to check the portal, but I think the tentative dates are 10th September to 20th September. So there is a complete week during which the quiz will be open. You can attempt the quiz any time during this duration, right? But it would be a really good idea if you attempt the quiz as early as possible, because technology always supersedes human. So don't just leave it for the last day. Okay. Please attempt the quiz as early as possible you can. This is one thing. The second announcement that has been posted is about the mid-semester examination. So I've posted the syllabus for the mid-semester examination. I will not repeat the syllabus right now. You can just go to the eLearn portal, or you would have even got an email regarding that. So please see that syllabus and prepare yourself, right? It's a closed book paper, 30 marks paper, right? And coming back to the quiz, your quiz is 3 marks. Right, so we will be having 2 quizzes in this course. Quiz 1 is of 3 marks and quiz 2 is of 2 marks. Right, so that will be the distribution. I will keep more information posted on the portal itself. Okay, there are a few questions that I'll take up regarding the quiz. How many questions in the quiz? I have still not decided, right? So since it's a 3 marks quiz, there might be 24 questions and 0.25 each. So that would come out to be from 6 marks, and then we would scale it down to 3 marks, right? The nature of questions would be MCQs or maybe true and false. There is no negative marking. and it's open for a week's duration. Okay, another question is regarding the weightage of assignments. Now, this is one next thing that we need to focus our attention on. The assignment will be of 20 marks, right? And the first step of the assignment will be to make groups. And so there will be groups of 3 to 4 people each in a particular group. And my understanding of implementing this is that I will not be able to give you people the choice to make the group yourself. Right? So there will be forced groups. I will upload the groups, and it will be really good that you connect to your group partners and work over your assignments. Okay, so this is the next agenda. Next week I will finalize the groups, and subsequent week I will upload the quiz, so that I will upload the assignment, so that the first phase submission of the assignment is somewhere before mid-semester examination. Right? I think you people are not so much interested in listening to my assignment concept, but there are questions coming about the quiz. Quiz will start from 10th September and will end on 20th September. Still, please check on the eLearn portal the dates for the same. I will upload the dates again. I think in my previous mail, in my previous announcement, I have not uploaded the dates. I will upload the dates again. Syllabus for each one of them has been uploaded on the portal. Please check the portal for assignment, for the announcements, right? I think we'll move ahead. So these kind of questions, queries, you can keep on posting, right? There's a question that is coming up, is the assignment time bound? Right? This is something that I do not have an answer to right now, because it's been 2 years since I have taught in non-specific course. Okay, so previously the scenario was that it was not time bound, right? But I need to find out if things have changed in these 2 years, right? I will upload the announcement of the same on the portal itself. Okay, so if it's time bound or how many attempts are allowed. I think any number of attempts are allowed and it is not time bound. But I will still upload the announcement. So whenever I upload an announcement, you get an email according to that, right? So please don't worry about that. And in case you do not see the announcement in next 4 to 5 days, you get free to send emails to me. Okay, so one person says that for the other courses, it is not time bound. So yes, definitely it would not be time bound, I think. Okay, but I will still post the announcement. Fine, so let us start the class. Enough of discussion about the operational issues. We have a lot of content still left to cover. Okay, so today we are going to focus on system sequence diagrams, right? Let's see what is system sequence diagrams. Now, one very important thing before I start what is a system sequence diagram, let me first introduce that there are two separate kind of diagrams. One is a system sequence diagram and the other is a sequence diagram. So given a question, you have to be really careful what the system says, whether it says a system sequence diagram or a sequence diagram, right? Now let's see what happens in a system sequence diagram. A system sequence diagram illustrates interaction of the actors with the system and the operations initiated by these actors, right? It shows at a particular time for a particular scenario of use case, right? So by this line, we can understand that a system sequence diagram is drawn for a use case scenario. This is the first thing. Then second thing, that it shows the events that the external actors generate, their order, right? So order of events is very important, and the other inter-system events that might occur, right? The entire system is treated like a black box, right? The emphasis of the diagram is the events that cross the system boundary from actors to systems, right? Let us first have a look of one such diagram so that we understand what are we trying to study. This is one system sequence diagram which is adapted from your textbook, Larman, and this system sequence diagram represents the system sequence diagram for process sale scenario for the next generation point of sale system, right? Now if you see here, there is one actor who is the cashier, and there is a system which is my point of sale system, right? There is a dotted line here, this one, which shows the lifeline of this particular actor, and there is a dotted line here which shows the lifeline of the system. Okay, there is a request to zoom. I think even if I zoom, it might not zoom for all of you, so you please use your own screen to zoom it. Okay, so on the left hand side, you would find a zoom button. Okay, maybe it's zoomed. Fine. So we'll have a closer look at this diagram. This is my cashier, the external actor, and this is my system, right? And then there are lifelines. There are messages that are flowing from the cashier to the system, and then there are messages flowing from the system to the cashier, right? This is what a kind of a diagram we are trying to draw, right? Let us see the notations ahead, and then we will understand this diagram and as well as draw a few of the system sequence diagrams. So let us see the notations. The notations for the system sequence diagram. The class name, a semicolon, a colon followed by a class name is used to represent an anonymous object of the class, right? So the system, or in this case the system, we represent the system and put two dots or a colon before the name of the system, which represents an anonymous instance of the system, right? So I'll just take you back. So here if you see, it's written cashier. Maybe it's not visible, but there are two dots that are put before the cashier. So it shows an instance of the cashier, and here it shows an instance of the system, right? Mind you, whenever we are drawing a system sequence diagram, there will be only one instance of the system. We treat the entire system as a black box and create one box which represents the instance of the system, and we draw a line which is its lifeline, right? There could be multiple external actors in a system sequence diagram, but there will only be one single system. Right? This is very important to remember. We will not break down the system into domain, objects, or analysis class. The moment we break down the system into analysis classes, then it becomes a sequence diagram. It is no longer a system sequence diagram. So when we are drawing a system sequence diagram, the entire system is represented as a black box, right? I'll go back to the next slide. Okay, so coming to the notation, the entire system is represented as a black box. A vertical dotted line represents the lifeline of each of the object, right? So the moment we put two colons before a class name, it becomes an anonymous instance of that class. So in this case, our system is one whole system, and there is a instance of the system that we are considering, and there is a lifeline. A cross on the lifeline shows the end of life of the object, right? So there might be an external stimulus which results in end of life of the system. So that is represented by a class, right? All requests, messages, or events from the actors to the system are drawn as solid arrows, right? So this is very important. All messages from actor to system are drawn as solid arrows, and response from the system is represented using a dotted arrow, right? So all requests or events from actors to system are solid lines, whereas all responses from the system to the actors are dotted lines, right? Okay. Now what is written on the top of these lines? So all requests and events from the actors are labeled as method calls or function invocation, since they invoke some function or code in the system. Okay. Events from actor to the system are solid lines, and on top of them you will write method invocation calls. Whereas on top of the response from the system, which is represented using a dotted line, the system writes the data or the report or the message generated from the system to the actor, right? So let's just go back to the previous diagram and confirm the notations again. Right, so you can see here, this is one solid line which is going from actor to the system, and the end arrow is a filled solid, right? Then coming to the next, maybe this one, this is a message or information coming from system to the actor, and it is a dotted line and it is a non-solid arrow, right? It is very important to capture these notations because these notations have weightages, right? So even if you've got the entire SSD correct, but if your notations are incorrect, you lose almost half the marks. Okay, so it's like that, right? It's almost half the weightage is for these notations, right? So you have to be really careful about the notations. Okay, lines from the messages going from the external actors to the system are solid lines with solid arrows, and coming back from the system to the actor are dotted arrows. Okay, let's see if there are more notations to add. Right, that's it. Okay. Now in a system sequence diagram, the time proceeds downwards. Okay, so there is a vertical lifeline. The lifeline represents time increasing downwards. The ordering of events should follow their order in the scenarios, right? So as I just told you, system sequence diagrams are drawn for use case text scenarios, right? So so we have to in a way depict that textual information in the form of a diagram. So whatever is the flow of uh, the text or the steps in a use case text scenario, the same should be the ordering of events in the system sequence diagram, right? Okay. Next, something called as interaction frames are used to show loops in a sequence diagram, right? We will understand what is a loop. Let me just go back to the previous slide, uh, zoom it a little. So in this case, here is one loop, right? So if you remember, when we wrote use case text scenarios, we said that, say for example, there is step 3 and there is step 4. Right? Now step 3 and step 4 is repeated n number of times, right? That is one concept of loop that we use in use case text scenarios. In order to convert that into a diagram, SSD introduces the concept of loop, right? So it's a big box. Let me just try to get a marker. Something's happening? No. Okay. It's a box like this, right? You can see this box which has this word loop written here, right? And it loops more items, right? So in case you know how many times it will loop, you will write some n number. Otherwise, simple more items. And these are the two messages on which a loop is specified, right? So in this next generation point of sale scenario, the cashier enters an item, the system displays the total, then again the cashier enters the item and the system displays the total, and this goes on till more items are there to be added, and then finally the cashier gives a end sale request to the system, right? So this is how a loop is represented. Okay, coming back. So my SSD is a pictorial representation of a use case text scenario, right? And one very good question which has now been raised is that, do we specify the alternate scenario, right? And the answer is no. Sorry, okay, no alternate scenario in SSD, right? So whatever SSDs you will see, you will find that it tries to capture only the main success scenario of the use case text scenario, right? Only the main success scenario is what is captured, right? With this, I finished the notations, right? So we will take up an example right now. If there are any questions, I'll just take up 2 minutes. Okay, somebody says that in this particular SSD, there is no end of life in the figure, right? There is a notation for end of life. It might not exist in this particular example, but it does exist. So there might be a scenario that the instance of system ends because of an external stimuli, right? So if the system, if that happens, then we or after a particular event coming from the external actor, then we will put a cross below the lifeline of the system that the system has closed down, right? Some of you say that loop is not clear. I will take up an example, and I think that has a loop, so it will become more clear. One question I do not understand, does it mean that any 1 to n relationship or n to 1 relationship or n to n relationship need to be shown in loop? I really don't understand your question. It's just a loop that I'm specifying, simple for loop. Simple loop over a few events which is going to happen is represented using this. Okay, there's another question which says that could you please provide one example where we cannot use system sequence diagram but sequence diagram and vice versa? The two diagrams are different diagrams, right? System sequence diagram is the first level diagram which is drawn to directly convert the use case text scenarios into a pictorial representation. In later iterations of the elaboration phase, when we have our domain model also ready and we know what are the analysis class, then the idea is to refine the system into its analysis class and decompose the system sequence diagram to draw the sequence diagram, right? So they are not replaceable by each other. They are created one after another. So system sequence diagram is the first step. Using the system sequence diagram, you decompose the system into its analysis class, and then you draw the sequence diagram in later iterations of the elaboration phase, right? So they are not alternates to each other. Okay, fine. I think that's it. No more questions. Okay, let's take up an example. Okay, this is the one. Now for the snakes and ladders case study, we draw the system sequence diagram for the use case scenario of the game owner configuring the game board with S snakes and L ladders, right? We have to draw a system sequence diagram for the use case scenario of a game owner configuring the game board with S number of snakes and L number of ladders. Okay, let's see. Let's have a look at the diagram. I again zoom it, right? We'll continue to see the latter parts. Let's start with the top. So I have here one instance of the game owner. The game owner is an external actor which is interacting with my system, right? And I have complete one instance of the snakes and ladders system. Okay. There is this lifeline of the game owner and there is the lifeline of the system. The first step, game owner sends a message to the system, initialize board. Okay. It's a solid line going to the system, ends with a solid arrow, right? And on top of the line, you write a method invocation call, right? So usually the concept is an actor invokes a method being executed, existing on the system. Okay. Continuously there's a question coming. there's no stickman figure drawn on the top of the game owner, you can definitely draw a stickman figure, right? The stickman figure shape was not available in MS Office, so I didn't purposely drew it. Yes, but you can draw the stickman figure to emphasize that it's a human external actor, right? Okay. Okay, there are some questions coming. I don't know which. Okay. Then, in response to this initialized board, the system sends a message which says, which is display board UI, right? So the system displays the board UI and prompts the game owner to enter the number of snakes, right? There's a question which says, uh, what is the difference between a solid arrow and the dotted arrow? You can see for yourself here, right? This is a complete triangular arrow. So it's a solid arrow. This is what we called as a solid arrow, right? It's filled end. Whereas this one is not a solid arrow. It's an open arrow. It's not filled, right? This is the difference between a solid arrow and a normal arrow. Right? Okay, I think I make myself clear. Then it says, then the game owner sends the message, enter snakes, and gives the number of snakes that it wants to enter. Right? So S is the number of snakes that it wants to be placed on the snakes and ladders board. Right? I'll just remind you of the case study. So the case study was that the snakes and ladder system has a configurable board. The game owner is the person who is responsible for configuring the board. He can specify the number of snakes and ladders that are to be placed on the board. Plus, for every snake, the game owner is supposed to enter the starting and the ending point of the snake, as well as for every ladder he has to do the same thing, right? Once all this entry is done, then of course the system creates the game board and then it is used further, right? Okay, so the game owner enters the number of snakes, which is S. Now for each snake, the starting point of the snake and the ending point of the snake has to be entered, right? So what do we mean by that? The mouth of the snake and the tail of the snake has to be entered. So here the system, once the game owner enters the number of snakes, then the system prompts the game owner to enter the starting point and end point of the snake, right? Then he enters the starting point and then enters the ending point, right? And this loops, right? So it has to loop any S number of times, right? So here you can specify loop S number of times, or you can specify till more snakes pending, something like that, right? So you can write in any way, right? Okay, then once the entry for all the snakes is done, then the system asks the game owner to enter the number of ladders. The game owner enters that he wants L ladders, right? And then similarly, it loops over the ladders. The game owner is asked to enter and starting and end point of the ladders. And once this loop is also complete, the configured board is displayed to the game owner, right? So this is a system sequence diagram for configuring the snakes and ladders on a board, right? Okay, I'll take up a few questions that are coming in. enter start point SP and enter end point SP should be two solid arrows. Okay, this message, this event is what this person is saying, that can we put this event into two events? Yes, you can club them, you can separate them out into two events. I have clubbed them into one single event, right? Do we need to define SP and EP? No. It's just at the uh, use case scenario level that you are operating. So we do not know what is SP, what is EP. It's just a variable that you will assume, right? The exit condition is till more ladders are still existing. Right, so instead of writing more items, you can write till more ladders are to be are left, or till more snakes are left, right? You can very well see from your side that in this particular diagram, the alternate scenarios are not captured at all, right? So the user might end up entering wrong values for start point or end point. This is something which is not captured in the SST. It is only the diagrammatic representation for the main success scenario, right? So it is very important that please do not capture the errors in this case. Okay, I'll take up few more questions coming up. Okay, one question is that enter start point. I have used the variable name SP, and here I have used EP, right? The same variable name is SP and EP is what I have used here also. You wish, you can change the variable names for the start and end point of the snakes and start and end point of the ladders, right? But logically, if you see, this loop ends and then only this loop starts. So there will be actually no overlapping, right? So that is the reason I have used the same variable names. If there are any constraints, can we mention above the arrows? Yes, you can. Can we use different function names? Please use logical function names. Of course, they will be different from what I have written, right? Can we separate start and end point methods? Yes, this was a question asked by somebody else just now. This message you can separate out into two events: enter start point, enter end point. Okay, I've got a spelling wrong here. Sorry. Okay. Can we combine the two loops in one loop? Can you do that? You need to think about this, because if there are the number of snakes and ladders are different, then you will not be able to combine the loop, right? So keep it separately. Can we use colors in the diagrams? You want to carry your sketch pens to the examination hall? Please, you can do that. There are no if-else conditions that we specify in the system sequence diagram. The notation for it comes in the sequence diagram, right? There was one question which asked that what is the difference between I just forgot. Are there more rotations in the system in the sequence diagram, right? So your system sequence diagram has less number of rotations, whereas your sequence diagram has a large number of additional notations. And those additional notations we will see when we will go through the sequence diagrams. Okay. Okay, there's a question, can we just write enter start point instead of writing as a enter start point with brackets, right? Uh, the idea of using the brackets is to represent a method invocation, right? And this is what I explained while explaining the notations as well. All the events from the actor to the system are method invocation calls, right? And what system returns is some data or message or report. So as far as possible, all the events from the actor to the system should be in the form of method invocation calls. I think I've answered most of the questions. Sequence diagram is interaction diagram, right? So there are two type of interaction diagrams. One is sequence diagram and the other is communication diagram, right? So in our next session, we will go through interaction diagrams, one of which is a sequence diagram and there is communication diagram, right? Okay. I think enough of questions on this. Let's move on to the next step, right? So these are the activity diagrams, right? Okay, one more question. That's a very funny question. I don't know. Will the snakes and ladders or point of sales case study will come in the examination? I don't know what I should give you an answer for this. You please go through all the case studies that we have discussed, but definitely you will not get any question directly from any of these case studies. You will get a new case study on which you are required to understand and draw the diagrams which are asked for, right? Okay, I think that's it for the system sequence diagram. I have one more example of the system sequence diagram. Okay, I think I still have time for that, right? So then later we can spend 1 hour on the activity diagram. So I'll just share my screen because it's in a Word file. Okay, right. And I'll open the chat also. Okay, this is another system sequence diagram. This is for inviting a player to join the game in a specified mode with specified number of coins. Okay, if you remember, we had written this use case text scenario where where the game owner invited a player to join the game in odd or even mode with a specified number of coins, right? So let's see what do we have here. There's no marker in this, okay. Okay, before I could start, there's a quick question which has come up why there are two actors in this, right? So I mentioned while I was mentioning the system sequence diagram, my system is the black box, right? But there can be any number of actors that I might represent as per the scenario in the system sequence diagram, right? So this was the main reason why I drew this particular diagram, to show you that it is not always the interaction between the two of them, the game, the one actor and the system, right? There might be an interaction by n number of actors with the system, right? In this particular scenario, there are actually two actors which are involved, right? Because the game owner sends an invite to the player to join the game, right? Let's understand this particular system sequence diagram, and then uh, I'll answer your questions, right? One quick question that I'll pick up is that uh, why not place all the actors on the left and the system on the right, right? This is very true. You can place them anywhere. The placement that I have done in this is with the idea so that it is more clear, right? But even if you place game owner and then you place the player and then you place the system, it's correct. Okay? Okay, let's see this. So there's a game owner here, my snakes and ladders, and the player, right? Each of them has a lifeline. The game owner sends a invite, right? The system forwards this invitation request to the player, right? Then the player, again if you see, it's a solid line. The player is invoking some system event, right? So player says accept invite. Okay? Then my system sends this to the game owner. Invitation request accepted by player P. Right? Alternatively, what you can do here is you write, give this player a name. Right? So the moment you type in P here, it no longer becomes a anonymous object, but it's a named object. Right? And it is the name object P to which the game owner is sending a invite request to. Right? Okay, once the invitation request has been accepted, the game owner sends a message to the system, get the mode request, right? The system sends a mode request, sends the message to the player, mode request by the game owner, odd or even, right? The player sends back mode selected M, right? So M is the mode that has been selected by the player. The system forwards this request to the game owner, M mode selected by P, right? I'll just scroll down. Okay, then the game owner says, get the coin. How many coins does the player want to be placed on the board for him, right? So he sends a coin request to the system. The system forwards this request to the player, number of coin requests by game owner, right? The the player sends back the number of coins, which is then sent by the system, says n coins selected by P, right? Once it is all done, the game owner says to the system, display board UI, right? So it invokes the display board UI, and finally the system returns the board UI to both the external actors, right? This is your system sequence diagram for inviting a player to join the game in a specified mode with specified number of coins. Okay, now I will take up few questions that are moving in chat. What is mode request? If you remember the case study, the player can join in even or odd mode, right? So if he joins in even mode, he will be able to move his coin only if he gets an even number on the dice, otherwise not. Okay. I am not able to read the chat because the messages are flowing very fast. Let me just try and pick one by one. Will this SSD be posted on the portal? Yes. No need to draw till the game ends. No. If the scenario focuses only on the use case text scenario of the game owner requesting the player to join the game. That's it. Right? This was the focus when we wrote the use case text scenario. The same will be the focus when we are drawing a pictorial representation of the use case text scenario. Okay? Okay, there's one question. Can the arrows jump across the lifeline of the action or a system? Right? Please try and draw in such a way that there is no jumping that you have to do. Right? In case it is absolutely necessary, then I don't know if you know, there is a semicircle kind of a symbol which is drawn to represent that there is a jumping, right? Number of events in a lifeline are fixed, or it depends on the user to draw. No, it depends on the user to draw. There is no fixed number of events or messages that can flow on the lifeline. Okay. Here we are not converting the use case diagram to SSD. Here there is no user case. It's detailed implementation with function and loop. We are not converting use case diagram into SSD. Very right. We are converting use case text scenario into SSD. These are two different things, right? So you might have missed out the previous session in which we discussed use case text scenarios. We are providing, the system sequence diagram is providing a pictorial representation of use case text scenario. Okay, one good question. But if the order of actor and system is interchangeable, right? So if I place on the leftmost side, if I place the game owner and then I place the player and then I place the system, right? Then one of you say that instead of sending the invitation message to the system by the game owner, I would send the message directly to the player. Right? No. That is the wrong way. Okay? The game owner will send the message to the system and system will send it to the player. Logically also you think the game owner will not maintain instances of the player. Right? It is the system which will be maintaining the instances of the player. The player will join the game. The player will not join the game owner. The external actors all interact to each other through the system. Right? The external actors all are connected to the system and they all interact with each other through the system. The game owner will not directly send a message to the player. Okay? I'll just see more messages. If we have 3 actors in one system, how will we place them? All the actors on one side, system on the other side, any way you can place them. Okay? If the interaction with one of the actors is pretty less and more with the 2 actors, then you can place the 3rd actor on the right side and club the rest of them together. The placement is only to be done in a way so that it is more readable. That's it. For one player, there should be only 1 coin, then why coin count? I think you've not read the case study. The case study says that each player can join with any number of coins. There is no failure case. If the player doesn't accept the invitation, we do not capture alternate scenarios in this, right? The SSD only captures the success scenario. So we do not go to the alternate failure scenarios. Okay, P colon player, where player is the class name and P is used to name the object. Okay, the question is, I've written P colon player, right? So till P was not there, it was an unnamed object of class player, right? It is called an anonymous object. The moment you put some characters in front of the colon, you give it a name. So in this case, it is the P object of the player class. It'll be really good if you yourself get down, pick up the same case study and draw some other use case, draw some other system sequence diagram, right? So just visualizing it and understanding it will not help that much until and unless you draw some diagrams yourself. Okay, please do not come to the examination so that your examination is your first instance of drawing such diagram. Please don't do that to yourself. You must draw and practice some diagrams beforehand, right? I will also try that I expect the submission of the assignment before the mid-semester examination so that you have drawn some diagrams yourself. Okay. Okay, we'll just take a 5 minute break here. I will go back to the slides and we'll come back after 5 minutes and take over the activity diagrams.